Hey, welcome back. I'm just checking on the last of those quizzes, and then let's get started. But first, let's see how you did. Okay, pull this one out to show you. We got an average of 93 this time. Most people got it. It occurred to me after I wrote it that you could have just made a pretty good educated guess just knowing the number of tires on cars and bicycles. So, if you did that, congratulations on your logic skills. But since the average was pretty high, I'm not going to go over it. We'll just leave anybody's individual questions uh, to them asking me after class or during office hours or whatever. I never get a haircut. No, I haven't had a haircut since the pandemic hit. Not because I don't want to, just because why bother? I'm not going anywhere anyway. Alright, so today let's finish up our sandwich shop thing first. And as we're doing that, we're going to get into another one of the letters in the Liskov, another one of the letters in the solid principles. We learned about Liskov substitution, the L. Today we're going to take a look at the O. The O is for open to extension, closed for changes, essentially. So open for extension is the O. And what the O means is that once you've built a parent class, and O is really more applicable to large projects, but it's something that you should think about too. Once you've built a parent class, children should be permitted to extend the parent class and do whatever it is that they need to do. But once you've finished a parent class and you've called it done and you've integrated it into your program, you should not change it anymore. And the reason, for example, in a situation like this where we have finished our sandwich to a point and we've got the parent class food and we've got everything extending food and we've already done some stuff implementing food, if we suddenly decided to make a change, like something beyond a variable rename, let's say that we wanted to change the way that calories are computed or something, or change the way that the cost is computed, divided by 2, for example, or something, I don't know. This change now cascades out to so many different places in the program because cost is computed in so many different other places. And if we made a change that was breaking, like for example, we decided, all right, calories and cost should be a double now, let's say. This would cascade out even more. Who knows what kind of issues this causes? And even worse, it doesn't actually cause any kind of exceptions. It's, it holds up everywhere because you can still pass in ints to double fields, but the implications are probably going to be substantial. So after you've written a parent class and integrated it into your program, you should be very wary of making changes to it. Remember, this is a guideline, not a hard set rule. Sometimes you do realize that you messed something up in the parent, and you really do need to change it, but be careful of making changes to parents that already have lots of inheriting children, because those kinds of changes can break large portions of the program. And those kinds of changes are the most dangerous and difficult kinds to make. Okay, let's finish the sandwich store's functionality. We had this sandwich going last time, and we made this new array of food to store the ingredients. in addition to all the fields that we had before that were of the child type. So we had a bread field, a meat field, a sauce field, a veggies field. Okay, and we could get rid of these fields if we wanted to. If we got rid of them, what kind of system could we use to figure out where's the bread, where's the meat, where's the sauce, where are the veggies? So let's say that I didn't want these anymore, so I got rid of them. What kind of system would I use to determine where in the ingredients array is the bread, where's the meat, where's the sauce, and where's the veggie? What could I do instead if I didn't want to have two copies? What could I do instead of having these fields? If I wanted to still be able to address the bread, the meat, the sauces, and the veggies, what could I do? It's actually kind of a hard question because we've done this before. We've done something like addressing all of the indexes individually. So something like bread index would be 0. That's fine, right? But when you get to the part where you have to address the sauces, how do you do that? Because sauces is an array. It takes up multiple spots in the ingredients array, and it's also not clear how many. It could be 3, it could be 4, it could be 10, and then the veggies come after it. So what would we do if we wanted to be able to address all the sauces and the veggies separately? What do we do on this part? And if we didn't do this, if we didn't address all the indexes, and we just stored everything as we did here, we just stored everything into the ingredients array, how would we ever know if something was a sauce or a veggie or a meat? We wouldn't. And remember, one of the principles that we want to follow is that we should never check. And so if we've constructed this array already, we should never be checking if an ingredient is a sauce or if it's a veggie. So if that's relevant for some reason, and in this case it actually isn't because all 4 of the child classes don't do anything different, but if it was relevant for some reason, then we wouldn't be able to perform that check. So while you think about how to do this, sauce index array, okay, sauce index, well, it starts at 2. All right. But then what do you do for topping? For veggies, when I say topping. What do you do for veggies? Well, for veggie, it's not going to be static or file, because for veggie it varies. Sauce is always going to start at index 2, but it depends on how many sauces you're going to have. How do you figure out this one? And I could still make this uppercase for consistency or not. Up to you. Veggie index array start. How do I figure it out? It's related to sauces.length, but then the sauces portion of the array actually starts at index 2, so we'd also have to add that too. So yes, we could do it this way. We could say that the veggie index array start is sauces.length plus 2, which is the so if you have one sauce, then the first index of the veggies is going to be 3. If you have 2 sauces, then the first index of the veggies is going to be 4. So this is complicated, right? And that's why a lot of the time when you want to address items individually, you're going to do it like this, even though this means that you have two copies of all the same foods. We just have everything in there twice. We've got the bread in there, and then we put the bread into the food array, and so forth. So let's say I'm going to do this just randomly in the constructor. Would this statement evaluate to true? Oh, it's called ingredients. And I guess I should use the index I made. Is this statement true or not? You can answer, but I'll do a poll. Is it the same bread? So is the bread that's stored in this dot bread the same as the bread that's stored in ingredients of 0 in the food array? Let's run it and see if we get that to print out. Oops, I did not run the right thing. Okay. So it does print that it's the same bread. Right? So it is actually the same. So everything that we've made, not only a copy, they're actually the same object. So they're not just identical pieces of bread, they are the same piece of bread. These are two different references referring to the same piece of bread, because in different situations we find it more convenient to address them individually or as a group. All right, and to make this interesting, I'm going to go to sauce, and I'm going to add another field to sauce. Let's call it int smoothness. Okay, and sauce just has a smoothness of 1, whatever, just to differentiate all the classes a little bit, right? So if I wanted to calculate the total smoothness of a sandwich, I would need access to the sauces specifically. So if I wanted to write something like public int get smoothness, I would have 2 options. I could do loop through all of the sauces. That's the easy option because I have that available to me. And then add to the smoothness as we go. That's option 1. Option 2 is to get them from the food array, which is a bad idea because it's difficult. But how could I do that? Let's say that I didn't have a sauce array at all and I needed to do it through food. So how can I get it through my ingredients array, which is of type food? So it's going to be for food, F in ingredients. I don't have smoothness as a field of food. It's only a field of sauces. How do I do that? Let's do a different loop here. Yeah, we would unfortunately have to cast as a sauce. And if we cast as a sauce, well, that creates a bit of a problem too. Because although this statement is going to parse fine, right? If we try to use it, if we go to the driver, and let's say after we make our first sandwich here, we do system.out.println. It's called BBQ chicken. and we do the get smoothness alt, when we run this, we're going to experience a crash because the bread was attempted to be cast as a sauce, which is incorrect, of course. So how could we successfully perform this cast to sauce in a safe way? Any ideas how we can cast only the sauces as sauces and not cast the other objects? Show you some of the other things we have available to us. And this is again assuming that you didn't have these individual fields for the individual kinds of ingredients. Yeah, I could check if the ingredients, if I is not equal to the bread index, I also just have all the sauces indexed, so that could work too. But yes, we could skip over 0, 1 in all of the veggie ones. If we just skipped over the bread one, then we're just kicking the can down the curve to another problem. If I is not equal to bread index, will cause it to crash once we reach the meat index instead, since meat also can't be cast as a sauce. So then we could add something else. We could say, alright, well then, or and I is not equal to the meat index. Sure, let's go with that, and then everything's fine until we get to the vegetables, which also can't be cast as a sauce. So that's difficult to do, to exclude all the other objects. How do we do the opposite thing? How do we just include only the sauces? Now we do have this sauce index, but that's just the start of the sauce array. There are more than one sauces potentially. There's an array of sauces. Actually, for the sandwich we're talking about, there's just the one sauce, the barbecue. But let's say that there isn't. Let's say that there's more than one sauce. How do we get all of the sauces? We've got this sauce index array start. What can we do with it in order to only attempt to cast the sauces as sauce and nothing else, so that we don't accidentally trigger an exception? And also we have the suggestion to filter out the vegetables as well, using the way we filtered out the bread and the meat. We could do that. So in an array that we structured the way that we've structured this one, where everything has its own little spot, we could change the for loop that we've written so that it starts at the first sauce and then ends at the first vegetable, because that's where the sauce array ends. And so I've designated the end of the sauce array and the start of the vegetables using this veggie index start. So I could go from the first sauce to the first vegetable, and then I should be able to get the smoothness, which is 1 in this case. And it should still work if I add another sauce. So for example, if I was to make this a double barbecue, I added another barbecue sauce there, well then it would still be working. Now it's 2. So it's a plain chicken, barbecue, onion lettuce sandwich. Alright, so obviously this is a far more confusing approach, so the more that you can avoid having to do this kind of casting, again, the better. This is not something that you want to normally do, but it's something that you will run into situations at some point when you probably have to. Not on the homework that you've got now, I think, but at some point. Alright, next order of business is to fix the store. We haven't rewritten it yet to accommodate the not enum version. So the enum version, if you'll recall, was very long and quite complicated. So how can we make a randomly generated sandwich, or a sandwich with random ingredients? And then the print inventory method should still work. If a sandwich is null, so there's an array of the sandwiches that the store has, it's called its inventory. If a sandwich is null, then it just prints sold out. All of these are sold out right now because I've commented out this whole method. And at the beginning in the constructor, we make 10 random sandwiches to put into the store's inventory. So how can we rewrite this monstrosity to accommodate our new inheritance version? When we were dealing with the enums, we had to pick between the 3 different bread values and everything, and that was a pain in the butt. So how do we do that? This is going to be my output, I guess. That's the sandwich. How do we pick a random piece of bread? Here's the bread class. Doesn't really have a ton of options. And here's the sandwich class. And here's the, where is it, the food class. Here we run into a bit of a problem, right? The 3 different bread types are all listed here. And then the brisket, pork, chicken, etc., all there too. And I haven't really given the properties of each of the breads like I had in the original enum version, where the calories and the cost were associated with each specific kind of bread. So it was better, in a sense, in the enum version, when you could say, well, wheat has 5 calories, and rye has 10, and plain has 6, or whatever. You were actually able to specify those. Not exactly true of this version, so there are some disadvantages here as well. And another of the disadvantages is that it is actually quite a bit harder to write this. Let's uncomment it and see how we can fix it relative to the new version. So undo the to-do and get started. So rather than looking at bread.values, which doesn't exist anymore, it's food, I think. It's food.foodname.values. And rather than picking from the entire one, we have to pick between 0 and what? That's 0, that's 1, that's 2. So we're picking between 0 and 3 now. That is not exactly ideal, is it? So since we used the magic number here, we would have to go back and do a similar thing that we did to the sandwich. We'd have to do the same thing where we list the start and the end indexes, and it would be quite a painful mess. And so realistically, what we did here was not great. This would be very hard to fix. So I'll leave that as an exercise to you, because I don't think you really want to see that. But something to think about is that, well, let me actually leave the to-do in there as well. Something to think about is that this is a pretty complicated consequence of making a change to what was basically the parent of this. So going back to that O, open for extension, closed for modification, really shouldn't have modified the parent, because we made this functionality practically impossible to accomplish. Okay, let's put a close to the sandwich shop for now. Some changes to save. And let me review one more time how to get the Git integration set up, because I think a lot of people still haven't quite gotten to it. So if you've got it built in correctly, which most of you will if you installed Eclipse through 9.8. You would go to Window, Show View, Other, and you can find the Git repositories and the Git staging view here. You're going to open the Git repositories view to get started. So again, that's going to be Window, Show View, Other, and then you're going to find the Git repositories. And let me actually sync this up before we continue. Okay, all synced up there. Hopefully. All right, once you've done that, there's a couple of configurations that you need to make under Window Preferences. You'll find them in Team and Git, and the options that you have to type in and everything are listed in the tutorial that I linked. So check that out if you haven't done it already. That's just going to be where you enter your email and your name that's associated with your GitHub account. So if you've registered a GitHub account, you'll have your name and email there. You're going to want to input those into the place that it describes. And from there, it's pretty simple. So you just have to hit this green silo kind of button there, clone a Git repository, and add the clone to this view. So in the Git repositories view, hit that button. It will ask you for the URI, and you will enter the URI of the class GitHub here. It's, go back to it. There we go. And at that point, you would connect to it. You've got your password and everything stored, hopefully. If not, it will just prompt you when you've attempted to pull it, and you can get all of this stuff loaded in after that. So again, just hit that little green silo, clone a Git repository, punch in the URL of the class GitHub, the 129 sync GitHub page, follow the instructions there, and everything should be pulled into your Eclipse, and you can have all of these examples available to you right there. And in order to sync with the remote version, so after I've made a change, you can either re-import it or you can make a pull, a fetch request, and then you'll see the difference between yours and mine. You can accept it or not accept it. Maybe I'll show you that last time. We'll see if everyone can get the first part there set up. So try to get at least the 129 sync with all of the projects imported. The reason I want you to do that today is because we, of course, have an exam on Tuesday, and it would be very helpful for you to have all these examples loaded in. Now, you can also load them in from Canvas, and just like I did last time, I'm going to make another zip folder that contains all of the examples that we've done up to this point. You can get to those as well. All right, new package. We're going to start a new one. I'm not going to do the random sandwich again. I don't think that's a great use of time. So let's do another that's going to be called the almost Liskov example. All right, I'll make a driver class first. And then I'm going to make a parent class for everything else called bird. Okay, what kinds of birds are there in the world, and what are all birds capable of doing? What are some properties of birds? What can all birds do? And what kind of birds are there? I'm going to make a few kinds of birds, and then we'll compare them all using their properties and the different things that they can do. So we got a fly method. Birds have a fly method, and if you've got a fly method, then you've got to have something like an altitude. Altitude. Every bird's altitude. Let's go with public bird gets a starting altitude. Hopefully I spelled altitude right there, but if not, whatever. Alright, and you get some certain number of height there, and we'll say that every bird gets a certain amount of altitude per flap, altitude per wing flap, or altitude per fly. Take that in as an argument as well. So birds have bigger wings, smaller wings, right? This dot altitude per fly equals altitude per fly, and every time you flap your little wings, it goes flap, flap, and then you get higher up. So add to your altitude, you gain altitude per fly every time you flap your little wings. So flaps your little wings to go higher into the sky. Increases, and then we could link them if we were being nice here. Altitude by altitude per fly. Alright, and somebody already mentioned a problem with our specification, so let's go ahead and make class penguin, which is a bird. Penguin extends bird. Well, it's a bird in the real world. That doesn't mean it has to be a bird in our program, but we're trying to demonstrate exactly this issue. So let's go ahead and add the superconstructor. Well, what's a penguin's starting altitude? What is a penguin's starting altitude? And how much does a penguin gain altitude for every flap of its beautiful penguin wings? Zero, and it gains 0. Alright. So, is this a violation of Liskov substitution or not? I'll take a poll. Is this a violation of Liskov substitution that the penguin is configured to have no altitude per flight? Got a couple answers, and I'll wait till some more come in. And while I'm waiting, let's create another bird. Go with pigeon. I'm going to take a starting altitude as an argument for the pigeon, because you never know how far in the air the pigeon is, and we'll say the pigeon gets 5 altitude per flap. Alright, so most of the votes are on no, it doesn't violate the Liskov substitution principle, and no is probably the correct answer here. Some people would argue yes, but no is probably the most correct answer here. And the reason that no is the most correct answer is because our implementation of bird didn't make any promises as to the limits to altitude and altitude per fly, and it also didn't make any promises as to what happens after fly executes. So 0 is a perfectly valid option for both of these fields, and an outcome like this, where the altitude doesn't actually increase because the altitude per fly is 0, is also a valid outcome. So the penguin actually does meet all of the criteria of its parent class bird here, in the sense that we didn't promise that there would be any increase in altitude for flight. So even though penguins can't fly, and they are technically not complete replacements for their parent, They are complete replacements for their parents in this application because we didn't say that the flight actually has to do something. And so that's a common situation that you'll run into where you have one child object that inherits most of its parents' properties but then is maybe missing something. As long as it's missing that functionality in a way that isn't a problem anywhere in your program, and in this case, you can't really conceive of a situation where it would be a problem that Penguin doesn't gain altitude every time it flies. Well then, you can carry on, and that's not a Liskov violation. But what can penguins do that other birds can't? So, birds can fly like pigeons, and penguins can't fly. So what can penguins do that other birds can't do? Well, most birds, probably. Other examples. Duck-billed platypus of birds. Penguins can waddle, right? So where should the waddle functionality be specified? Should we specify it on bird? Should we specify it on penguin? Yeah, I should specify it on penguin because it's unique to penguin, and that also goes back to the open for extension. We don't want to modify our bird class to accommodate one of its children. So take that as another one of the lessons from that principle. If you need to modify the parent to accommodate the functionality of a single child, you should also be wary of having to do that because that's usually a mistake as well. Not always. Again, guidelines, not hard rules, but if you're modifying a parent class to accommodate a single child, then you probably have a mistake. So penguins can waddle. And it just says, wanna waddle. Okay. But let's say that we have an array of birds. Birds equals new bird. Just give us 10 options here. We'll pick them at random again. Pigeons need a starting altitude, remember? So I'll just assign them one randomly as well. Let's just go with, whoa, not the one I was going for, guys. Math.random times, say 100 for the starting altitude, and I think that's supposed to be an integer. Okay, so there's my array of birds. I can have them all fly. Let's do that first. So they can all fly. That's easy. Flap, 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 flap. But if I want them all to walk as well, or if I want them to waddle. So birds of eye. Let's say I want all the penguins in the scene to waddle. How do I get all the penguins in the scene to waddle? You don't know where they are, so unlike the sandwich shop example, they are spread out all over the array because they're assigned randomly. So how can we create a way for our penguins to be able to waddle here? How can we create a way for our penguins to be able to waddle here? We certainly don't want to add waddling to bird because, well, not all birds waddle actually. Only penguins do. But here's a hint. Does waddling fall under a broader task? Although we could type them, right? That's always the intuitive solution, is to give each bird a type. So we would designate something like, all right, penguins type 1, or penguins type penguin, pigeons type pigeon. It's always the tempting way to go, but it will inevitably end in overwhelming complexity. So to write good object-oriented code, you want to come up with solutions that never require you to check an object's type. Only in the most extreme cases will you do that, and generally speaking, that kind of case only falls under the you have thousands of lines of legacy code and you can't possibly go back and fix it type of situation. So how do we do it without violating that principle of never having to check an object's type? Yes, we could try and catch, so we could handle all of the exceptions as well. That's another sort of patch that you can do that's just before having to check types in terms of extremity. We haven't learned about try and catch yet, but you can ignore actually certain exceptions. But here's what I'm going for, alright? So waddling is actually a subtype of another activity. The activity that waddling is really a subtype of is walking. All birds can walk in some way. Okay, they all have feet. I think every bird has feet. I think that's probably true. Some have like flippers, but those still count as feet. So let's say that your bird can step. Bird walks. Okay. What can we do to make it so that penguins walk appropriately? Because penguins don't step. Penguins waddle when they walk. So what can we do to make it so that penguins, when they walk, which is what we're going to do here because that's what's common to all the birds, what can we do to make it so that penguins waddle instead of stepping when they walk? So we've added this walk method to our bird class, step. Okay, so we want to override the walk class here in penguin. So we're going to override our walk method. Sorry, I said class, I meant method. We're going to override the walk method here, and what are we going to do? Note the little arrow we got that indicates that we successfully did an override. We could change the waddle method to walk, so we could just kind of put waddle in there. That was somebody's suggestion. Or we could call the waddle method instead from the walk. I would usually prefer to do it this way if there's a pretty big difference in implementation. And in this case there is. They're completely different, or I guess not so much. They both just print two things, but we can call them completely different. And now we can see basically how many penguins and birds we ended up with based on how many times it says waddle waddle. So that time we only had one penguin. This time we had a few. Right, so you could do this kind of thing for typing as well. In some instances you can check what the response is going to be. So let's say that waddling returns some number, or walking returns some number. We'll change it to an int instead. Returns the number of steps. So return 2. Okay. What about Penguin's implementation? Well, I could have Penguin's implementation instead of returning 2. Let's say waddle isn't as effective of a mode of transportation, so it's going to return 1 instead. This allows me to differentiate the penguins from the birds without checking their types. So this I would consider to be a valid and acceptable way of differentiating objects. So as you go through all of the different walking birds, you could say if birds.walk is less than 2, then we'll print out that this was a penguin. Continue. So there are ways to differentiate objects besides checking their type. Based on their properties, it's perfectly fine to make distinctions between objects based on their properties. So now all the waddlers get a printout. And at this point, you could also even safely do something like this, right? You could safely do birds of I dot waddle by casting this as a penguin, because by this point you know that all of the objects that you're getting are going to be penguins. Should you do this? Probably not still, because even though you are able to, what happens if you make another bird later on that has a walk of less than 2? Well, then this is going to break. So again, still avoid this, but there are ways to do it safely, at least in the short term. Okay, one more thing, I guess, with the bird example. Let's make another bird called eagle. Eagle's also going to extend bird. Eagle's going to have a very high altitude per fly. Let's call it 20. Okay, and I'm going to add a method to eagle to eat another bird. So we're going to call it public void eat, and it's going to take another bird as an argument. Whenever I take another of something as an argument, I like to call it other to be more clear. Okay, I guess to accommodate this, we'll add another variable to our bird. We'll add a boolean is eaten, like we've done before, set that equal to false. Okay, so if this eagle is higher up than the bird that it's trying to eat, I want it to be successful, and if it's lower down, then I want it to fail. So how would I implement that? If this eagle is higher up than the other bird, then it eats it, otherwise it fails. Somebody asked in the YouTube chat if the exam is including inheritance. We are going to have inheritance on the exam on Tuesday. It's going to be closer to the kind that you saw on the quiz than maybe some of the longer ones, but you should expect to be able to write some inheritance code. The format is going to be similar to last time. You should definitely have your swing starter ready to go so that you don't have to fuss around with it. There's going to be some swing component to the questions. So close, the answer in Discord uses the starting altitude. We want something like that, but what are we looking for rather than the starting altitude? We want if the eagle's current altitude exceeds the other birds'. Altitude, right? We just call it altitude. So if it's greater than the other bird's altitude, then we're going to eat them, which sets other dot is equal to true. And we can describe this as eats the other bird if this bird is up. Then that one probably isn't the clearest description, but sure. Okay, let's make an eagle. We'll make it separately from the rest of the birds. And the eagle will start 50 units up, which puts it rather in conflict with some of the pigeons. Okay, so we're going to attempt to eat some of the other birds. What can I pass in to other here? Give me an example of a argument that I could supply to eat, a valid argument that I could supply to eat. My only recommendations from Eclipse here are to eat eagle, which is probably not what I want to do. I don't want to eat myself. So yes, I could supply one of the array arguments there. And I actually didn't print anything out on a successful eat, so I should probably do that so that our simulation has some kind of output. We'll go with num num on a successful eat. Okay, so if I run this, most of the time I'm probably going to have a num num because it's unlikely that a bird is going to spawn high up enough to beat our eagle. Oh, there we go, we got an example where it didn't. Pigeons can spawn as high as 100 units high, so it's possible. But all penguins, of course, are just going to get eaten immediately by the eagle. But let's say that we wanted to change that. Let's say that we wanted eagles to be unable to eat penguins specifically. So if we wanted to add that functionality, if we wanted to add the ability for eagles to eat all pigeons, but not to be able to eat penguins specifically. So let's say can't eat, and then to do penguins here. What can we do in order to make it so that eagles are unable to eat penguins, again without type checking the penguin? Let's see that that's what we have. How can we verify that the other bird is a penguin, or that it's inedible without checking that it's a penguin? Yeah, we can check for grounded birds, because only penguins are ever on the ground. So we could use one of the proxies that penguins has, so we can verify that the other dot altitude is not equal to 0. This actually protects the pigeons that are on the ground too, though, doesn't it? So that's not the best property to use because it's not necessarily unique to penguins. So that would protect all the pigeons that are on the ground, which we don't want to do. Any other properties that we can use that are unique to penguins? And of course, we could always add another property. The reason that an eagle can't eat a penguin is because the penguin's too big. So the real answer to this question would be to add a size property to the bird and verify that, because that's the actual reason that this isn't possible. We could check the penguin's stepness, as we did in the other part. We could check that their walk result is less than 2. Could do that. It's unique to penguins at this point, although that might be a problem for if we ever add other birds. Or we can check if the altitude per fly is not equal to 0. This would probably be my preferred mechanism, because then we can say more specifically that you can't eat flightless birds rather than penguins, and that meets all of the criteria for not violating any kind of type checking. So now, most of the time we run this, we're not going to get a num-num, because the first guy is a penguin, and they can't get eaten. Only if the first guy is a pigeon, and they are sufficiently low to be eaten, would they be eaten. So, different ways to approach it, and obviously most examples aren't so contrived and using real-world objects. Can we check if other.waddle is not equal to null? No, there is no waddle on bird, right? No waddle on bird. So we've got about 7 minutes left. I can do a little bit more with this example, or I can answer any inheritance-related questions before the exam. Anybody got any questions? If not, I'll just add another fancy feature to this. Can't eat flightless birds like penguins. Implements obviously won't be on the exam. We haven't started it yet, so it's just going to be the single inheritance, the extends. The only time implements will be on the exam is for mouse and keyboard stuff in the swing starter, but you don't need to understand it to use it. That's all set up and everything already. So again, make sure that you have your swing starter ready to go so you can just start adding classes and code to it. Yeah, somebody asked what abstract methods are. So if a method is abstract, that means the class has to be abstract too. And in cases like bird, the class really should be abstract, because there's no such thing as a bird. A bird is an abstraction. You can never make a bird. You can only make a kind of bird, a penguin, an eagle, a pigeon, whatever. But if a method is abstract, let's say walk becomes abstract. For example, I don't want to do it to walk because I already wrote code for it. So let's make a new one. Let's call it abstract void bird call. Okay, so first, your abstract method doesn't have any body. It just ends in a semicolon, which is an unusual declaration. And what the abstract method is a promise that every child will implement that method in their own way. So whereas with a non-abstract method like walk or fly, all of the children inherit it and they inherit the functionality, and they can use that parent's version of it, the abstract method has no version of it for the parent. There is no generic bird call. Every bird sounds different, right? So every child now needs to implement that, and if they don't, then it's an exception. So we need to add this unimplemented method here. What do penguins do? I guess they squawk. Let's see, what do pigeons do? They meep. and eagles they chant USA. Okay, so that's the 3 calls of these birds, and if we go back to our driver and go through our bird array and call each of their bird calls, we can see what kind of birds they are. Do a bird call. You notice abstract methods get a special color in most of the formatting guidelines. We can also do it for eagle. This eagle's not part of the bird array. Squawk, squawk, meep, meep, USA, USA. So an abstract method is a promise to fulfill a method, but not a definition for one. All children must then implement that method to fulfill that promise. And that allows you to take for granted that all birds have for bird call and be able to use it accordingly. So you would use an abstract when you don't have a default or an expected way for all of the common creatures to do something, all the common children to do something, but you still want all the children to be able to do something. So there's no common bird call, but all birds have one. So you make a promise that all birds will implement one, and then you implement it individually in all the children. Let's see. A few more minutes left, and looks like no more questions, so let me show you one more example of how inheritance can go bad. We've seen how inheritance can go bad when the parent is insufficient, or when the children need something the parent doesn't quite have. But what if we're in a situation like this? So we've designated bird as one of our parent classes. It's got a method called fly, right? Fly flaps your little wings. But then what if we suddenly decided that we're going to add a class called airplane? Is an airplane a bird? Should airplane extend bird? It does most of the things that bird does. Airplanes have an altitude. They have an altitude per fly. They can't really be eaten. They can definitely fly, but they don't fly by flapping. And they can walk, kind of. They have wheels, so they roll rather than walking. What can we do in order to accommodate airplane in our inheritance model? Should we start all over? Because if we started all over, then we would have to really copy quite a bit, right? All of this would essentially be identical. Airplanes don't flap their wings, but get the idea. Moves engines. That's basically the only difference. Between a bird and an airplane. And of course we don't want to repeat ourselves that much. So this is another problem that you will run into with inheritance. You have an object that is very similar but not quite the same. And in order to accommodate it, this is closer to, I guess, the duck-billed platypus problem, you would have to build a whole new inheritance hierarchy where most of the information is duplicated and identical. And that's obviously a problem because we don't want to duplicate. So there's no right answer in this situation. You can refactor your bird into a flying creature instead. The best choice is probably to see what's common to both airplanes and birds and make yet another class, a parent class for both of them, called flying thing. Flying thing. And rather than having your bird or your airplane extend bird, you would have both your bird and your airplane extend flying thing. Okay, that's going to be it for today. So exam next time. See you then. I'll upload this along with flying thing.